In this video, we're going to be testing a mean with an unknown sigma. And our problem reads, because many industrial wastes contain nutrients that enhance crop growth, efforts are being made for environmental purposes to use such waste on agricultural soils. Two researchers reported their findings on experiments with brewery waste used for agricultural purposes in the article Effects of Brewery Effluent on Agricultural Soil and Crop Plants. The researchers studied the physiochemical properties of effluent from Mohan Meakin breweries and its effects on the physiochemical characteristics of agricultural soil, seed germination pattern, and growth of two common crop plants. They assessed the impact of using different concentrations of the effluent, 25%, 50%, 75%, and 100%. The following data, based on the result of the study, provided the percentages of limestone in the soil obtained by using 100% effluent. Does the data provide sufficient evidence to conclude at the 1% level of significance that the mean available limestone in the soil treated with the 100% effluent exceeds 2.3%, the percentage ordinarily found? And they tell us that the x bar from our data is equal to 2.5 and S is equal to 0.149. And it's important to notice that we don't have sigma here, we have S. So because we have S and sigma is unknown, then we're going to use the t-test, and then we know that our x bar is 2.5, our mu is 2.30, and we also need to know that we're using 1% level of significance, and it says effluent exceeds. So the word exceeds is going to tell us that we're using a right-tailed test, and then we need to know our n, and in this case our n is 10. And I got 10 by looking at our sample, and we can count that there's 10 numbers here. So now we know that we're using a t-test and we're going to be right-tailed, so we're going to create our null hypothesis and our alternative hypothesis. So our alternative hypothesis is mu is greater than 2.30, and our null hypothesis is going to be mu is less than or equal to 2.30. And then we want to find our critical value, and in this case it's going to be a t crit is equal to. And now when we have an unknown sigma and we're using t, we also need degrees of freedom. And degrees of freedom is equal to n minus 1. So since our n was 10, our degrees of freedom in this problem is 10 minus 1, which is equal to 9. So now we go to our t-chart, and we have 1% significant, and we're one-tailed. So one-tailed over to 1%, and now we're going to go down to 9. So we have 2.821. And now we want to set up our rejection regions. So we're going to say we're going to reject H naught if T-calc is greater than 2.821. And now that we've found our critical value and set up our rejection regions, we want to find our T-calc. So T-calc is equal to x bar minus mu divided by S divided by the square root of n, and that is equal to x bar was 2.5 minus mu, which was 2.3, divided by S, which was 0.149, divided by the square root of 10. And when we put this in our calculator, we find that it's 4.245. And since our t-calc is greater than our critical value, we're going to reject H naught. So we have reject H naught. And now we want to write a conclusion for our findings. And our conclusion is, at a 1% significance level, our data provides significant evidence to conclude that the mean available limestone in soil treated with 100% effluent is greater than 2.3%. And for t-tests, we can't find an exact p-value without having a calculator or a computer. So if you were asked that question, you would need to do it on the calculator or the computer. And that's our video on testing a mean with an unknown sigma.